So what we're doing here today is I'm showing you how to calculate the ET50 value, the effective time value, which is a median, okay, descriptive statistic of a normal distribution. We're dealing with the rate of photosynthesis. So in your data table or your lab manual or your notes or the data you collected, we have basically a cumulative number of disks that floated. And we're going to put this in here. To make things simpler, let's just open up Logger Pro. And these are for my students. We certainly could do this on a graphing calculator or other different programs. But I'm using Logger Pro. That's certainly not a plug for them, but we're going to do that. So we have an X value, and the X value, okay, what we want is we want to have this as time in minutes, okay? And you guys collected intervals. So I'm just going to double click this, and this X is going to become, all right, minutes or time. Let's just put time. We know it's in minutes. Okay, and the short name for X will just do minutes, M-I-N. All right, and hit done. And then Y is going to be the number of disks that floated. Remember, photosynthesis, the rate of photosynthesis, if photosynthesis was what? Increasing, they're going to have more disks floating in a shorter time period. So we double click the Y and just put disks, D-I-S-K-S, okay? And what we're going to do here, and there goes our disks on the Y, and our X axis is time. We're going to put in our basically our intervals, our minute intervals, we'll say. So let's put 0, 1, 2, 3, 4, 5, 6, and again, I want to put a bunch in here. Most of our tests did not last this long, but I'm just going to show you. Okay, so what you have to do, for those that didn't understand, is you have to calculate this median time that it took for the fifth disk to float. And we're not just going to take the interval, we're going to actually come up with a value of minutes using a line regression. So let me show you. You're going to do this for every single test. So if you had an independent variable, let's say you were doing color of light, and you did white light, and you did 3 trials. Every trial you have to come up with an ET50. So let's say you took some data. I'm going to plug in some data, and you could take some data that you already have. Let's say we had 0 disks at a 0 time. And let me explain this time frame. I'm saying time of 0 minutes, but remember, we counted disks as an interval of time. So from 0 to 59 seconds, if there was a disk that floated from the bottom because the rate of photosynthesis was fast for that disk, we would put how many disks did that. So if there was one, this would be from time 0 to 59 seconds. So the first time minute interval would be from 1 minute to what? A minute and 59 seconds. And a second interval or a second minute interval would be from 2 minutes to 2 minutes and 59 seconds. That's how we're doing it. So I want to put in some values. I had no disks, and again, I'm just making up some data. You can put in some data to do one, okay? And then I put the first disk for me was in 2 minutes, and then maybe there was 2 disks that floated in 3 minutes, but I have to count the one that's already floating. Remember, this is a cumulative type of counting we did here. 3, and then another one, 4, and then there was maybe 2 more, okay, for me. So that would be 6 right there, and maybe 2 more, and then maybe we'll make 1 more, and then it stayed that way for a while, and then maybe the 10th one. Okay, so that's something that you should have had done in terms of how you counted how many disks. Okay, so once we've done that, you just plugged it in. Notice it made a line. Now what you could do is you could connect these lines. We can go into graph options. You can connect the lines, and basically what we're going to do, if 10 disks float, we want to find the time for the fifth. So I could connect this line here and then draw a line straight forward and try to estimate this time. Since I don't want to estimate, what I'm going to do is make a linear line out of this. So we're going to make a linear regression. So I'm going to hit the linear regression here. And again, if you're not using Logger Pro or using another, Excel you could do, or your calculator or anything else that you're using, just do a line regression, and I'll do that. And that made the best fit line through my data, and it gave me some statistics here. And that's what we're going to use. So basically what I'm doing, if 10 disks float, we're trying to find a median statistic here. We're going to take the fifth disk, and we're trying to find this value at this point here. Okay, now we could try to estimate this down here, but we have some values here if we do use linear algebra. We have y equals mx plus p, and two pieces of information you need here is slope, okay, which is 1.273, and the y-intercept, which is negative, in this case, 0.7273. Okay, and notice what the y is. The y is the disks. And I want the median disk. I want the fifth disk. So y is going to equal 5. And notice what the x is. The x is time. So I'm going to go to a blank page, and we're going to calculate for my data, or for your data, doesn't matter, what the ET50 was, the effective time, this median value for the fifth disk. So let's go to a blank page, and using the slope and using the y-intercept, we're going to solve for what the time is, x, okay, for the fifth disk. Right away, the fifth disk is here. Remember, you can try to draw a straight line. You can try to bring that down and try to estimate the time, but we don't have to. We can use linear algebra. So let's go. Okay, so we have our equation for a straight line, y equals mx plus b. We have the data, okay, the y-intercept from the graph, the linear regression line, the best fit line from the data. And now what we're going to do is we're going to solve for the time. Remember, the x was the time in minutes. And we know something. We want to know, because there was 10 disks that float. Remember, this is a median descriptive statistic, assuming, again, a normal distribution. We want this y to be 5. So we're going to solve for essentially x. We have y at 5 disks, because that's the median value. We have the slope and the b. So what we're going to do here is use some algebra and rearrange this equation and solve for x. Okay, so we're going to just kind of do minus b here. And it's an equation, so you do minus b to both sides. And what you get, party people, is you get, okay, y, and we'll just keep the minus b. And now we have equals, all right, mx. All right, now we're going to get rid of the slope, so we're going to divide both sides by m. And so you notice the slope will cancel, and what I'm left with, okay, is x, which we should know to be time, that was on the x-axis of our graph in minutes, is equal to y minus b over m. And so our time in minutes, okay, for the fifth disk, hey, that's going to be the ET50. All right, and so let's go calculate this. The y is going to be the fifth disk, because it's the middle, or the number of disks that floated. It's minus, now what is the y-intercept? Oh, that's minus also 0.7273, and a minus minus is plus plus. Okay, divide by my slope, which is 1.273. So we put that in our handy dandy calculator, and what we get is 5 plus 0.7273 divide by 1.273, and what I get for my value, if you're following along, is I get an ET50, which is a time in minutes, of 4.49. Now 4.499, let's round to do decimal places, so I get 4.50 minutes. Okay, and that is my ET50 for that set of data. You're going to do this every time for every test that you made. So again, if you did 3 trials for, let's say, a certain color of light, you're going to do this 3 times. Every time I want you to calculate the ET50. If we go back to our graph, this 4.5 is the result of finding at the fifth disk what the time was using the linear regression. Let's go there. You can see that the fifth disk, okay, it's about, right, 4.5 if you kind of rough eyeball it. All right, so that's what we do there. So what are you going to do now? Well, now that you get ET50s by doing this for every trial, you should go into a more advanced graphing program like Excel and start building a graph of them. So let's go there and I'm going to show you what you should do with your ET50s from there. Okay, so opening up Excel, and I just kind of made a plot, and I have 4 tests. These could be different colors of light, light intensity, whatever the independent variable you were testing. Let's say we did 3 trials of each. One might be the control, and I found the mean of these are all ET50s. These are values that we got, although I made up the data. Okay, so if we just did 4.50, let's say that should be here. Okay, so I can type that in, 4.50. All right, and you can basically set this up. Mean, we just basically put the average statistic, or in Excel, all you got to do is set this up to do the average for us. We have a way to do that. For instance, if I want to do the mean here, okay, I would go to formulas, I would go insert function, and I'd pick average. I'd say insert the function. It's going to ask me where, and I'm going to take the average of these 3 things, and then I'm going to say done, and it took the average. See there. And then if I want to do the standard deviation, let's below it. Okay, same idea. I'll take the standard diva, insert the function. It's going to ask me what numbers. I'm giving it the range, and booyah, say I'm done. I've got the SD. Now, the standard error of the mean, because what we're going to do here is we averaged our ET50s, and I got an SD, and now I want to make a standard error of the mean. Okay, notice I took E of 8. Remember, the standard error of the mean is the standard deviation divided by the square root of how many trials you have. So I take this value, which is E8. That's why I said equals E8. So this standard of the mean is equal to what? E8. Okay. And then I divide it by the square. SQRT is the term they use for square root. And it's divided by how many trials you have? 3. And I got the SEM. And this, of course, this is the first SEM. We want to do plus or minus 2 to get to 95% confidence. So we just times this by 2. So I took this value here, took my SEM, which again was just the value of E8, the standard deviation, divided by the square root of 3 trials. It gave me this value. I times it by 2. So right here, I said equal E9. That's for me. And I times it, little kind of star there, times 2. And that's my value. Okay. And so I want to graph these 3 things, so I can just kind of select these 3, and then I can do what? I can do, I can make myself a graph, and we can insert, and you can look at different graphs, and you can click on this, and essentially I've done that already. Okay, and I've done that maybe, and there is kind of my graph here. If I want to scroll down, get rid of this so we can see my beautiful graph, which I can see is a problem in terms of being transparent. But there's my graph, and I added some error bars. And to add these error bars like I did, make sure I'm in chart design. I come down to add chart element, and I'm going to do error bars, and I'm going to do more error bar options. And what I'm going to do is I'm going to hit custom like I have here. I specify the value, and now it's looking for the error bars. Now I've already done this, but for the positive value, all I did was select this area and hit OK. And for the negative, I selected the same area. It's plus or minus, okay, 2 standard deviations, and it made the error bars. Okay, and you can adjust all the little fancy colors to your heart's desire, but now you have yourself a graph showing the average. Now you don't have to use bar graphs. You could do a line graph. But what will I say here? Very important you understand, and please focus in here. I don't need this graph here. I definitely would like to see something along this line. Okay, and I'll definitely want the means. Okay, and so it's, if you need to show all of it, you can, but definitely this is important. I do not need you to show me how you got every single ET50. I would like you to do it once. Take a picture of you doing the ET50 for one of your trials. Remember, you're doing it for all your trials. These are all ET50s here. Do it for one. Show me how you did it. Put that in your procedure or your data section to show me as a researcher. If someone's reading your lab, you should know how these are done. Okay, but what I definitely need is another table of your ET50s and your average, and I need this graph with error bars, plus or minus 2 standard error of the mean. Okay, and one more point and I'm done. ET50s, if you notice something, this is going down, and people might say, well, photosynthesis rate is going down significantly, especially here. Remember the error bars here from test 3 to test 4. The ET50 is going down, but think about this for a second. If the time it takes for the fifth disk to float in your rate of photosynthesis lab decreases, isn't the rate of photosynthesis increasing? If the time it takes for the fifth, the middle disk to float decreases, that's a faster rate. So these bars going down, or a line graph if you do have it going down, is actually showing an increase in photosynthesis. One way to correct for this, you can actually do 1 divided by your ET values, or take your mean, okay, and take 1 divided by this, and what will happen, because the inverse, you'll have these bars going up. So the rate of this will be a 1 divided by ET50. If you don't like that, and you can understand that ET50s going down mean that the actual rate of photosynthesis is going up, be my host and do that. Okay, hope that helped.